remember how we're going to stay organized from yesterday. So if you need highlighters or colors, feel free to pull those out. I use a lot of colors when I do this too, to underline and highlight things. So the first problem we have is a clothing company makes pants and jackets. And they give us information about pants and jackets. I'm not going to read everything for you because you can read it yourself. But the jacket, it tells us it takes 1 hour to cut, 4 hours to sew. And then the pants that they make, it says it takes 2 hours to cut the fabric and 2 hours to sew the pants. All right, they tell us total time for cutting and sewing, and then a profit. Where did I say we start yesterday? Because we're going to have to identify our variables. Where do we always look when we're trying to identify X and Y? Profit. So it tells us we have a profit on a jacket and profit on a pair of pants. Now I'm just noticing right here, it does tell us that X is our jackets and Y is the pants, but if we aren't given that, because you're not always going to be given X and Y, the two things that you're finding profit from give us our variables. So we know that X is going to be for jackets, Y is for pants. So let's skip real quick down to D. Because D says write a profit function. And as we're talking about profit, we might as well write the equation. So remember, we said we're going to start with P of X comma Y. That means they profit from the two variables, from jackets and from pants. Right, so X is for jackets, right? How much does it say they make a profit on a jacket? 14. So we'll start with 14X plus how much is the profit for pants? 8Y. Good. So I at least know my profit function. That should be pretty easy to find. You find the word profit, 62 numbers next to variables. Well, now we need to figure out our system of equations. And yesterday I said that we need to make a table in order to create that system. And on your table, you're going to have a few columns. What always goes in your columns? Remember? Topic over here. X, Y, total. All right, those should always be your columns. And then we'll fill in. Usually we have about 2 to maybe 3 equations. So we need to figure out what are our equations about. What are the topics of these equations? What do you think? Cutting and sewing. They give us information about cutting for both variables and about how long it takes to sew. So those will be your topic. One equation about cutting the fabric. One equation about how long it takes to sew the fabric. Now let's look at X for jackets. How long does it say that it takes to cut the fabric for a jacket? 1 hour. So we'll put 1 in here. And what did I say you can automatically put next to that 1? An X. We're in the X column. We're going to put an X there because we're writing an equation. How long does it take to cut those pants? That's your Y. 2. 2 hours for cutting. So we're going to do plus 2Y. All right, let's talk about sewing here, then we'll finish the equations. How long do we sew a jacket for? 4 hours. So we're going to put 4X in the first box, plus, how long do we sew pants for? 2 hours, so plus 2Y. Now we have the meat of our equations here, but we need to make them into inequalities and then find the total amount of time available. So how much total time is available for cutting? 20 hours. Cutting is 20 hours. So put a 20 in the total. Now what symbol should I typically use here when it says you only have up to 20 hours? Less than or equal to. And same thing here. For sewing, there are 32 hours available. I can use less than those 32 hours, but not more. So we're going to do less than or equal to again. So those are the 2 equations that I have in my system. But I'm also missing something. What were the other equations I said you must always include? Yeah, the positives. So X is greater than or equal to 0. And Y is greater than or equal to 0. Why do I have to include those 2 inequalities? Yeah, I can't make a negative number of jackets and pants. All right, so now that's as far as we got yesterday. Today, we're now going to take those need to graph them. Because our goal is to figure out what it says in part E. Determine the number of jackets and pants that this company needs to make to maximize their profit. So they have a time constraint for sewing and a time constraint for cutting the fabric. Staying within those constraints, how much product do they have to make the most money? That's our goal. So to do that, we have to graph. Let's graph x is greater than or equal to 0, y is greater than or equal to 0 first. Which seems kind of silly, because what two lines is that? The x and y axis. But I do want you to graph them, at least like darken it in, because I don't like that line. Because it's going to help us see when we shade for our feasible region. So just darken that line in a little bit here as well. Just so you can see, all right, these are my boundaries. You have two equations already graphed. Now in order to graph the other two equations, what are you going to have to do? You're going to have to solve them for y. So I'll let you guys send the page here. You can start doing that while I'm making more room for myself. But I'm going to set up the equation here. X plus 2y is less than or equal to 20. To solve this for y, you need to move the x to the other side, which means you have to subtract it because it's positive. You get 2y is less than or equal to 20 minus x. And then you divide everything by 2. So you get y is less than or equal to 10 minus x over 2. That is the first equation, but rewritten so that you can graph it. Once you find that equation, you can go over here and graph that. You're starting at a y-intercept of 10, and then just like your quiz today, you want to plot as many points as you can so that we can find the intersection really easily. So I go down 1, right 2. Once you plot those points, you're going to connect them here. So if you're finding that you're running out of room here, just make sure next time make the table a little bit smaller so you have some. Okay, so now I have my next equation. If you're working ahead, that's okay. I have the equation 4x plus 2y is less than or equal to 32. Again, I move the x term over. It's positive, so I'm going to subtract it and get 2y is less than or equal to 32 minus 4. Again, I have to divide every term by 2, which gives me the equation y is less than or equal to 16 minus 2x. All right, any questions about the solving there? All right, so we start at 16. This one goes down to right 1. And make sure when you are graphing this, like mine does, that your points are going to intersect somewhere. If they don't intersect, you probably graphed your line incorrectly. Okay? We're only going to give you nice ones. In the real world, you might get decimals for things, but for our class, because we're graphing by hand, we want to make sure that you get nice whole ordered pairs. Well, how many lines did you graph? 4. So we need a feasible region with how many sides? 4. Where is that feasible region? Bottom left right here. Do you see this weird looking quadrilateral? That guy right there is your feasible region. It is bounded by all 4 lines. So now that I have found that feasible region, we're almost done. But we need to list the ordered pairs, the vertices of that feasible region. So sometimes I darken them in so I can see them for sure. Who can tell me one of the ordered pairs? 0, 0. That's an easy one. 0, 0. And then it looks like I have 8, 0. All right. What's another one? 0, 10, yeah. And the last one? 4, 8. Good. All right. those ordered pairs are combinations. They look like points, but in an application here, those are combinations of pants and jackets. Number of pants and a number of jackets that you can make to earn a profit. So we need to figure out which combination here of pants and jackets make us the most money. So you're going to use your profit function. Do P of. We'll start with the first point, 0, 0. You're going to test every single point here. Okay. Then you'll do P of 8, 0. P of 0, 10. And P of 4, 8. So I will give you a second here to work through solving those, setting them all up. I'll do the first ones and it's just kind of in the background. But you should get 4 different answers. So if I do 0, I take my profit function here and put 0 in for x. So 14 times 0 plus, 8 times 0. Which for that, you should end up getting $0. That should make sense. If I make 0 pants and 0 jackets, I make 0 money. The rest of them you should earn a profit on. So take a second here and put the rest of these into your profit function. And then we'll figure out which one gets us the most money. Did anyone find the profit for 8, 0 yet? How much is it? 125? 112. All right. What about for 0, 10? $80. And for 4, 8? 120. All right, so here's how we want you to write your answers. On your quiz next week, there will be blanks to fill in, but we don't have blanks on this paper. So first of all, we're trying to maximize the profit. What's the maximum profit? $120. So they're going to get, here's how you should write this. You're going to get a max profit of $120. So this company makes $120 when they sell. You need to write this as a sentence because it means something. It's not just ordered pair. So we get a max profit of $120 when they sell how many pants and how many jackets? What was X again? Jackets. So the X here are 4 means that when they sell 4 jackets, and how many pants? And 8 pants. Now you need to write that entire sentence down. Wait, does that put, some people are asking yesterday, does that put into context kind of what we're doing here? Alright, it didn't mean much when it was just a graph, but now it means something. And in real life, companies do this. However, it's normally on a much larger scale than 4 jackets and 8 pairs of pants. It would be like probably tens of thousands of products to work with. Okay. Let's try a different one. Let's go to the back. One more to try here. This one's going to look a little bit different once we set up all the equations. So it's just reading carefully. So it says the liquid portion of a diet should provide 300 calories. And I think where this came from was a problem I used to do about, we called it the astronaut problem. So it's like an astronaut for taking in food and fluid up in space. So for an astronaut, the liquid portion of their diet should provide at least 300 calories, 36 units of vitamin A, and 90 units of vitamin C every day. So you have a dietary drink. You have 2 drinks that you can choose from when you're in space. Dietary drink X and dietary drink Y. They both have calories, vitamin A, and vitamin C. It says, suppose dietary drink X is 12 cents per cup and drink Y is 15 cents per cup. We're going to use those values to figure out, what does it say down here? How many cups of each drink should you take in every day so that you minimize the cost, right? You don't want to spend a lot of money, but you want to get all your nutrients. So minimize is going to be a little different for us here. let's first identify our variables, which shouldn't be too hard because I kind of called them easy things. We look for profit, right? Remember profit or money? Well, here it says dietary drink X is 12 cents and drink Y is 15 cents. If that's our money stuff, what should X and Y be? X should be drink X and Y should be drink Y, unless you really want to make yourself confused. We were not creative with the names of these. So now let's write a cost equation here. We already are talking about money. We might as well write our cost equation. This time, are we talking about profit or something else? Just cost. So this time I would say instead of doing P of X, let's write this as C of X. The cost of drinks X and Y would be how much? Well, how much is drink X? 12 cents. How should I write 12 cents? 0.12. I'm going to do 0.12x plus how much is drink Y? 15 cents. So plus 0.15 Y. Now, we are going to set up our table. We're going to write a system right here. Okay? So we'll start with the same thing. And we're going to have, I'm going to tell you, we're going to need to write a little bit smaller for your table because you're going to have more solving in this one. You have the topic of your table, the X variable, the Y variable, and your total. Now, what do you think our equations are going to be about this time? Vitamin A, vitamin C. Okay, so vitamin A, vitamin C. And do they give you anything else? Calories. So this time we have a third one. That's okay. You still need to take in calories. So we want calories, vitamin A, and vitamin C. Those are the three constraints. Remember, constraints are rules. The astronauts need to follow those three rules. We need an equation for each one. So for vitamin A, how much vitamin A does drink X give you? 12 units. So we'll put 12X in that first box. How much vitamin A do you get from drink Y? 6 units. So I'll have plus 6Y. And then, what does it tell us for the total amount of vitamin A we need to take in? 36. Now, watch the word here. It says you have to provide at least. So do I want less than 36 units of vitamin A, or do I want 36 or more? 36 or more. So this time I need to do what symbol? Greater than or equal to 36. This is going to be a little bit different. All right, let's do the same thing for vitamin C. Vitamin C. Drink X has 10 units. So we'll do 10X here. Plus how much for drink Y? 30. Plus 30Y. And again, you have to go at least how much vitamin C? 90. Okay. And finally, we have calories. How many calories are in drink X? 60. Same for drink Y. So I have 60X plus 60Y. And how many calories do you at least need to take in? 300. So this time we have 3 equations plus which ones? X is greater than or equal to 0. Y is greater than or equal to 0. So really, how many lines do I have to graph? 5. All right. Let's start working on that. I would start with the easy one. Your intercepts. You can work at your own pace on this. I'm not going to talk through every single one, but I'll use yellow this time. Those are my first intercept and my second one. Your X and Y intercepts, just darken them in because it's going to look a little different this time. So you should darken them in so you can see. You know, every single one of these, you're going to need a little bit more space. So if you need to go somewhere else on your paper to write, that's fine. I'm going to move, I'm going to move this down so I have a little bit more room to write as well. Okay. So let's see. You can graph on your own. I don't think you need me to talk through it, so I'm just going to graph it up here so that it's on the video. But check your answers with me as I'm going to make sure that you got the right equations. So please make sure that you check that you're getting the right equations here as you graph. You're allowed to talk to each other. You don't have to whisper. It's okay. I promise you. Did I do something wrong here? No. Yeah, you're good. Okay. No, I know what's going to happen, so I'm not too worried about it. All right. Now we'll do calories. All right, 60Y. Oh, goodness, so much writing. That's the worst part about these problems is I feel like you just do like so much writing. Oh, yep, we're good. So the second one doesn't intersect like we normally think it's going to, but it's going to work out okay. But you have to figure out where you're going to shade this time. You might not want to shade yet. But you at least have lines that kind of look like that. Now let's think, as we're going to shade here, about the inequalities. Each one of these lines says y is greater than or equal to. Greater than or equal to? Greater than or equal to. Every other problem we've done has been y is less than. So when it's been less than, we've shaded underneath all the lines. This time, if it's greater than, where do you shade from the line? Above. So don't shade in yet. Let me just show you what's going to happen here. All right, so if I shade above those yellow lines, the whole thing would be colored in yellow. I'm not going to do that. We'll just assume that everything's shaded different. If I take this red line here and I shade above, that means you are going to shade out here. And again, just wait because it's going to make a mess. And then I'm going to shade above the blue line, which would then shade all this stuff. I know it's hard to see. And then the green line, we shade above it, which shades everything else out there, which really looks a mess. So can you tell where all the shaded regions overlap? Is it bounded this time? Is there a shape? No, it is shaded. I'll erase all this so you can see. What's shaded is the stuff on the outside. This is an unbounded region. Green is not a good color. So you shade outside of the most extreme lines here. All this up here. Because we're not limited this time. We're not trying to find the maximum. We're trying to find what's the fewest amount that I need to shade. to spend the least amount of money. So your shaded region is all this stuff above. There's not sides. But if you do count, you can see that all 5 lines do touch the shaded region. Bottom, the yellow, green, purple, red, yellow. That's all 5 lines touch that shaded region. So now we have to figure out where are your ordered pairs. So you have to be really careful. The first ordered pair is at 0, 6. Where's your next ordered pair at? Let's just try to go in order. Where did the 2 lines right here cross? 1, 4. And then after 1, 4, 3, 2. Yep. And then one more. 9, 0. So still have 4 points to check. 5. So I'm going to take a minute now. You're going to put those combinations. So this means you drink 0, drink X, 6 cups of drink Y. You're going to put all of those into your cost function so we can find the cheapest one. So take the last couple minutes. It won't take you that long. Cost of 0 and 6. Just be careful with your decimals. Go on through, you're going to put 0 in for X, so it'll be 0.12 times 0 plus 0.15 times 6. I'll have you guys tell me the answers in just a second. As you're finishing up, what's the cost for 0, 6? 0.9. So that would be 90 cents. 0.9, 90 cents. What's the cost for 1, 4? 72 cents. What's the cost for 3, 2? 66 cents. And 9, 0? $1 and how much? And 8 cents. You guys agree? Sure? Trust her. Well, what's the cheapest one? 66. So you have a minimum cost of 66 cents per day. When you drink, how much of drink X? What is your minimum? You drink 3 cups of X, and how much of Y? 2 cups of Y. Alright, that was a long one. We won't have another one that long. But you should be able to, I know I kind of skipped through the last part here because of time, but you should be able to evaluate those and get some